So to get started in lesson 2, part 1, we're going to focus on those properties of exponents as they relate to our fractional exponents. So all of that work that we did in trying to review our Algebra 1, we're going to use that with fractional exponents to evaluate some numbers and also to simplify some expressions. The goal here is to make sure that we can simplify radicals, but in order to do that, we just kind of have to get our exponent rules out of the way. So we're going to split this one up into a couple different parts just to make sure that we do a good job with the Algebra 1 and the pre-algebra so that we can do the Algebra 2 well when we get to actually do the Algebra 2. All right, so it kind of is delaying us getting into the meat and potatoes of the lesson, but I think that it's important for us to, again, think about all of these properties and all the ways in which we can apply these properties. So what I'd like for you to do here is copy down this table. All right, get that whole table copied. I've got a couple examples for each part. And what I would like to do is actually deal with these items in class. All right, that again is going to just force that practice and force that conversation, making sure that we can do the basic things with the Algebra 1 so that we can handle things when we get to do them with Algebra 2. All right, and so I want to have that conversation, but in class. This all has to be written down though, otherwise it's going to take us too long to actually do the thing in class if everyone's having to copy that down. So pause the video, copy that down. All right, but what we're going to want to do today is we're going to want to, again, connect the dots between the fact that when we have a number to a fractional exponent, it means that we're taking a power. And when we have a fractional exponent here, it means that the denominator is our index and the numerator is our power. So this can be written maybe in a couple different ways, like we did last time. So that, again, is not new, but we've got rules of exponentiation here. So this is actually 1 over 25 to the 3 halves. All right, we want to take care of the negatives because we can't have those negatives, which means that we've got the square root of 25 cubed. And so we end up with 1 over 5 cubed, which is 1 over 125. All right? With this, we're taking an odd root of a negative number, so this does exist. We are going to have negative 32's fifth root, and then we're going to take that to the 4th power. I always think it's better to make the number small before we take the exponent. Sometimes if it's easier to do the exponent and then take the root, then go for it. That sounds like fun. But here, this is going to give us negative 2, which then is being taken to the 4th power, which gives us positive 16. So we want to be able to execute those operations by using radical form, taking care of rules of exponentiation along the way as needed. Letters C and D for this example. We are going to, again, evaluate this as best we can. We've got the 5th root of 243 x to the negative 10th, and then squared. All right, so there's kind of a lot happening here. I have 243, it has the 2/5 power. And then this is again multiplied by x to the, this is going to multiply to give us negative 4. All right, it's going to get multiplied to give us negative 4. If you have trouble multiplying numbers by fractions, use your calculator, all right, because I'm probably not going to fix that today. All right, if I haven't fixed it yet this year, then we're just not going to be able to fix that. All right, so when I give that power to each of our factors, these will simplify some of those parts. So again, 243 to the 2/5 is going to be the 5th root of 243, which will then be squared. Over here, this is just 1 over x to the 4th. So that we'll put in the denominator at the end here. The 5th root of 243 is 3. 3 squared is going to give us 9, so we end up with 9 over x to the 4th power. All right? Over here, 8 to the negative 1/3 is 1 over 8 to the positive 1/3, and this is 1 over x to the 5th. These will combine in just a second to one fraction. The cube root of 8 is 2, and so we end up with 1 over 2x to the 5th power. All right, now remember the way that this works, the x has the 5th power, the 2 does not. All right, so we want to make sure that we are doing those correctly and understanding that relationship, that these things are multiplied and that 15 goes with only the x, not the 8 as well. All right, now more symbolic math, all right, and more fractions at that. So this might be a struggle for us, but that's why we have trusty technology that can do the elementary arithmetic for us. All right, so here, there's a couple ways that we can approach this, and I'm happy with either approach. I want to make sure that we do a good job with the things. And so sometimes folks will want to simplify the fraction first, take care of the x minus, or x divided by x to the 1/2, which would give us x to the negative 1/2, which is, again, that's fine, or I'm sorry, minus the negative. So this would end up a little bit funny, but we'll do that trick. So let's go ahead and actually just give this exponent to each numerator and denominator. And then when we do our subtraction here, we'll have 2/3 minus 1/3, which is going to give us x to the 1/3 y squared. Now we can leave it like this. Sometimes it will ask us to write it in, once we simplify it in exponential form, to then write it in radical form, which would be the cube root of x times y squared. So we put the y squared in front. This might look a little bit funny though, because we have a squared right next to a cube root index, so the exponent's next to the index, and that just looks a little bit funny. So this is really what we're going for today, but we want to be moving and thinking in that direction. All right, so keep up with that. Like I said, you could do this a different way. You could do, this is x to the 1, y cubed over x to the 1/2, and then that is taken to the 2/3 power. So you could do x to the 1/2 y cubed to the 2/3, and this would still work out the same way. This would give, if we subtract those, we get 1/2 here. So this would give us 1/3 and y squared. So we get the same answer in 1, 2, 3 steps. In 1, 2 steps, maybe it's a little less work to do it this way of just giving the exponent to each part and then simplifying from there. Here though, we're going to have to do our subtraction. So we're going to have x to the 2/3 minus 1/2, y to the negative 1/4 minus negative 1/2. And so we might need to use our calculators on that, and if that's the case, that's okay. 2/3 is the same as 4/6, 1/2 is 3/6, negative 1/4 and 2/4 would be the common denominators there. So we get x to the 1/6, y to the positive 1/4. This can be our answer, because we don't want to write our answers as the 6th root of x times the 4th root of y. That just looks a little strange, all right? So we don't want to go down that road. Let's leave it like this, and let's not write those in radical form. Obviously, if there's a numerical component, we'll want to address a numerical component, but when it's just variables, then we can handle the thing. Hopefully, that is enough as far as examples go. I've got a couple more here, but this should kind of round out our work. So, with this, powers of the same bases, we are going to add those exponents together. These are not common denominators, so we have to multiply the first one by 2/2 to give us 4/14 and 3/14, which gives us x to the 7/14, which is x to the 1/2, the same as the square root of x. Either way to write that is appropriate. Over here, we've got x to the 3/5 minus 1/10. Powers of like bases divided, you subtract the exponents, and so like I said, we might have to make common denominators so that we can do our subtraction, and then of course simplify any fractions along the way. And so again, we want that top answer. That's really what we care about today, is writing it in exponential form, but the punchline being that we're going to be able to work with that in radical form. Hopefully those examples made sense. If not, please let me know and we can discuss, so that you will be able to use properties of exponents and of radicals to simplify radical expressions. Now, that's the goal that we're going for in part 2. All right, so be ready with that.